Okay, 6th grade, how's everyone doing? Doing all right? Yeah, besides the rain, maybe, right? Or some of you might like the rain. Okay, our plan for today is to go over our 2 warm-ups. One of the warm-ups that I gave you, you probably did not know how to completely do it. The point of that is that we are going to talk about that today, distributive property and combined like terms. So sometimes I like to give you guys warm-ups that we haven't learned yet to make you think a little bit. Okay, sorry about the pause there, 6th grade. So anyways, the point of giving you a warm-up that you may not know how to completely do is to make you think a little bit about what today's lesson is going to be about. So some of you may have gotten the warm-up and not realized it on that second one. So we're going to go over that, go over your 2 homework assignments, and then I am going to flip back and forth between lesson 2.3 and lesson 2.2 today. You'll see why I kind of go back and forth between them once we get to it. All right, so from yesterday, we talked about area of a triangle and perimeter. Who can remind us of the area formula of a triangle? Charles? Good. Base times height divided by 2. Mary, what's the other way we could write it? Great job. Okay, so what is the area of this triangle? Annalise? Say that again. Good job. 40 centimeters what? Good job. 40 centimeters squared. Okay, what is the perimeter, Doug, of the triangle? 27. Good job. 27 regular centimeters. It's just units for perimeter, units squared for area. Okay, the next one. I guess I should have put tick marks on there. Did you guys figure out what kind of figure this was? I should have had these up there. Sorry. Alyssa? Good, it's a square. Alyssa, what did you get for the area? Good, 16 meters squared. Perimeter, Charles? Good job. Kind of weird they're the same, but they're actually different because 16 meters is different than 16 meters squared. One of them is representing the area, the other one is the perimeter. Emma M? For the triangle? Oh, you probably just added wrong. 12 plus 10 plus 5 is 27. Remember, perimeter is distance around, so you want to add up all the numbers around the triangle. Area is half the base times the height. Okay? Okay, anyone else in that warm-up? Doug? Yeah. No, the whole thing. Just do half the base, 5, times the height. So 5 times 8 is 40. Remember, I went over this yesterday at the end of class. There was a triangle just like this I had on the smartboard. Okay? Okay. Always the whole, if it looks like that, the whole thing. Half the base. Okay. Yeah, we didn't get to that yet. I just wanted to say one little thing about that because you guys always bring up things that we're learning eventually. Charles? Yeah. Yep. Yep. And you can do them one at a time. Yeah. And then add it together. It's just more work. You know what I mean? It's the exact same thing. Yes. Annalise? No. You split them up. This is 5, this is 8, this is 5, this is 8. The formula still applies. You still have to take half the base times the height. 2.5 times 8. 2.5. Yeah. Okay. All right, let's go to the second warm-up. Okay, second warm-up. We're going to go through these. I don't want you guys to ask too many questions because this is for today's lesson. So just double check your answers. I'm just curious to see how you did and how you used your common sense with math skills to answer these. So anyone wanted to try 1A for us? Annalise. 10 plus, close. Justin? Nope. Charles? Yep, how about B? This is today's lesson, so just if your answers are wrong, fix them. Doug? Good job, 6x minus 10. Letter C? Charles? Close. Good. 2A. How about some new people? 2A. Mary? 7X. Good job. 2B. Justin? For 2B, no. I know why you got that, but no. Charles? Good. 2C. Adam? There's not an A on 2C. This is a 9. Mary? Nope. This is a trick question. Sean? Nope. Trick question. Charles? Good. Why not? Yeah. These and this previews into today's lesson. Sometimes I like to make you guys think early in the morning. These are not like terms, as Charles said. So Charles' voice kind of sounded like, of course, that's common sense. They're not like terms. I haven't taught you guys that yet, so if you haven't heard that yet, you may not have known that. These are all different. Can't add them, and I'll explain that more today once we get to the notes. Okay, 3A, B, and C, you guys know. Annalise, letter A. Okay, good. Associative POM, property of, wait. Sorry, I just said yes, but POA. Nope. In between the terms, Annalise, is addition. See the plus signs? That's one term. You're just, yeah, always go by the symbols in between the parentheses. So thank you for catching me, MM. Mary. Good. 0, POM. Okay, 3C, Charles. Good. Identity, POM. Okay, so besides 1 and 2, because that's for today, so I'll come back to those. Any questions on 3? Okay, so let me just say again, 1 and 2, make sure you guys have the correct answers written down. After today's lesson, if you're still confused about them, we'll come back to them. Give me a thumbs up, thumbs down on 1 and 2. I'm just curious. Be honest with me. Okay, thank you. Okay. All right, let's go over homework. And we're going to start with the homework from the notes. So page 5, number 1 and 2. I just am going to ask you guys what you got. So Donatus, for number 1, can you tell us what you got for the perimeter? Good job. Emma H, what'd you get for the area? Good job. Alex, for number 2, what did you get for the perimeter? Good. For the area, Matt, what did you get? Good job. Everyone, check over those. Annalise? For which one? Okay, did you, for perimeter? Okay. Okay. Anyone else on 1 and 2? Shh. Okay, let's go over the book homework. Okay, so that was page 70, numbers 1 through 8. Sean? Yeah, you can get your book. Thank you for asking. Okay, I'm going to read through these answers, okay, pretty quickly so we can get to the notes. So check your answers. If you're not sure of something, let me know. Okay, number 1, 36 feet. Number 2, 34 meters. Number 3, 73 inches. Number 4, 324 inches squared. Number 5, 600 centimeters squared. Number 6, 30 meters squared. Number 7, the area is 4,200 feet squared. The perimeter is 268 feet. Number 8A, square A is 12 feet. Square B is 24 feet. 8B, square A is 9 feet squared. Square B is 36 feet squared. So let me pause before we talk about C. Okay, does anyone want to try to tell us how the perimeters are related? So we'll first start with the perimeters. Briar, what do you think? perimeter? You're talking about area. But you're correct about the area. Did you write anything about the perimeter? Okay, it was both of them. Just make sure you read carefully. Zach? Good job. So I didn't write it up here, but for C, the perimeter of square B is twice that of square A. For the area, just like Breyer said, the area of square B is 4 times that of square A. So some kind of relationship like that. This kind of relates with what Donatus told us yesterday. You remember that problem yesterday on the homework, that you give a different way of solving it? You basically used what we just explained in C, whether you realize it or not. Annalise? You were relating area to area and perimeter to perimeter. You're supposed to be relating the perimeters and then the areas separately. Okay, Annalise? Okay, you were relating these two and these two. You had to relate the perimeters and then the areas. Okay, this is 2 times as much. This one is 4 times as much. Emma M? That could kind of work. Not the best, but that could kind of work. I see where you're coming from. Donatus? And that's what Emma M said. That works. That works. Because it's true, but I just wanted you guys to be a little more specific, but that works. Doug? Yeah, that works. Yeah, that works. Annalise? Multiples of. That works. Charles? Perfect. You went the opposite way. I actually probably like that better. The book's example does it the opposite way. I like that better. Okay, anyone else? Questions on either of the homework assignments? So I need a thumbs up, thumbs middle, thumbs down on area and perimeter of a triangle, rectangle, and a square. And remember, we didn't learn Pythagorean's theorem. Okay, and we're going to come back to it. I have a warm-up tomorrow we're going to do that relates area and perimeter to these figures again. Don't forget, I always come back to things. We're always spiraling it. You guys learned that in chapter 1, especially with types of numbers. All right, is everyone okay? Okay, so now let's try to figure out what the combined like terms and distributive property thing was on your warm-up. Now, here's where I need you to skip around a little bit. I need to start with page 9 in your notes. So I need everyone to flip to page 9 in your notes. And then we're going to come back to the page we were just on. Okay, so page 9 in your notes. Here's what I need to do. I need to do a couple definitions with you guys first. We're going to do an example with like terms, and then I'm flipping back to the distributive property. So we're kind of learning 2 things today, but I don't like the order your book does it. Your book teaches distributive property before like terms. That's not a very good thing to do. So first definition on page 9, I need you guys to jot down, is a term is the parts of an expression or an equation that are added together. Terms, the part of an expression or an equation that are added together. And I'll show you what a term can be. Here's an expression. This is a term. This is a term. This is a term. It's extremely important the sign in front of it stays with it. That's a negative term. That's a positive term. That's a positive term. Annalise? No, it's for anything. Yep, give me a second. I'm getting to that. It's for anything. So parts of an expression that are added together, that could mean subtraction, because remember, you can also add negatives. But a term basically is explaining any kind of expression or equation. What is it made up of? Emma, H, you okay? Okay, you sure? Okay, Doug? Yep. Okay, second definition, like terms. Terms that have the same variable parts. I just talked about this with 9th and 10th grade algebra the other day. Like terms. Terms that have the same variable parts. This is probably new to most of you. What do I mean when I say variable parts? I mean it has to have the same variable and the same exponent. So variable parts. Same variable, same exponent. If negative x and 2x are like terms, who can give me another example? If negative x and 2x are like terms, they have the same variable parts. Adam, what's another example? Awesome. 6y and 7y. What's another example, Emma M?
8x.
Good. 8x and x. Annalise, what's another example? Good. Is 2x negative? This is negative. No, that's positive. If it was negative, there'd be a negative sign in front of it. Okay. Justin, what's another example? Good. A and 3a. Doug, what's another example? Good. B and B. So here's some, I wrote 2 examples down. The only thing you guys didn't mention was something that was like squared or cubed. So these are like terms. These are like terms. I could throw a negative in front of them, and they're still like terms. Same variable parts means same letter, same exponent. These are like terms. I can't stress this enough. This is something you will see all throughout math. When I teach this in algebra, I have pictures on my smartboard, and I always relate the numbers to money. And I relate a variable with an exponent of 2 to a 2-headed cow. You guys ever seen a picture of a 2-headed cow? I'll have to show you tomorrow. I also relate variables because they have an exponent of 1 to a 1-headed cow. If the variable has an exponent of 3, a 3-headed cow. Why? Because they're alike. Okay? They are like terms. It's like saying Alyssa and Emma M both have red sweatshirts on today. They are like. They are alike because they have the same variable parts. I'm just kidding. They have the same sweatshirt on, right? So they could be like terms if we're talking about relating clothes, you know, like things that you guys have on, colors. Mary? Yeah. I've never seen that. If you, okay, yeah, that's very weird. Okay, okay. If your hand is up, questions on like terms. Emma M.
Could like 6 cube and 7 cube?
Yep. Yep. Annalise.
Would the y and like if it was negative y cube or squared and y squared, wouldn't the y in the second one have to be negative?
No, they don't have. That doesn't matter. They have to have the same variable parts, same variable, same exponent, or they just have to be numbers. By definition. Yep. 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 Same. All. The only restriction is same variable parts. We don't care about positives and negatives. Charles. Correct. Okay. Multiplication is completely different than addition and subtraction. And I'm getting to that, so hold that thought. Okay, coefficient. Does anyone know what a coefficient is? Can anyone explain it? Charles, can you explain it? It's a number. Okay, give me some more though. Doug? Okay, no. Emma H? Okay. Mary? Awesome. Coefficient is a number part of a term with a variable part. A coefficient is a number that is next to a variable. Very important you remember what a coefficient is. It's the number that's in front of the variable. Coefficient, the number part of a term with a variable. Coefficient. Sounds weird. You will also hear this all throughout your time in high school math. Adam.
So
So it's the number part of a term with a variable. We're going to do an example in a minute where I mix all these terms up. Please remember, guys, when you learn something, it takes a day or two to actually for it to sink in. So don't feel like you should immediately get it all right now. Okay, I'm just explaining and giving you guys an overview. Emma M. Yes, only a number. Okay, this part's easy. A constant term or a constant is a number term, but no variable. Constant term or constant is a number part, but no variable. So a constant term is any number. Now, not a number in front of a variable, because that's a coefficient. A constant term is like 5, 10, 70. Anything that is just a number. Annalise?
So it means just like a regular number.
Yep.
Like in the term, there's no
Yep.
other.
Yep. Mary? You probably did. Yep. Justin? Yep. Donatus? You solved? Oh, jeez. Good job, Donatus. Charles? No. Yep. Good question. Yep. I'm getting to that. You guys are a little ahead of me. Annalise? Yeah. Negatives, remember, negatives and positives all fall into the definitions. They're not different. They're just a different way of looking at a number. It's still constants, still coefficients, whether it's positive or negative. Alyssa? Yeah. Yep. Okay, let me do an example. I think this will answer some of your questions. Okay, so let's do example letter A. We need to identify the terms, like terms, constants, and coefficients. So, hold on one second, Adam. Of this example, anyone want to try to tell us what the terms are? Try without looking back. Justin? Awesome. The terms are every part of the expression, or if it's an equation, of the equation. Great job. Adam? Not necessarily. Doesn't have to be the cube root of a negative number. Okay. We'll get into that. There can be. Wait, let's stick to questions on this. You guys are way ahead of us. Okay, like terms. We're bringing it down like 4 grade levels. Like terms. Can you guys give me 2 sets or 1 set, whatever you think there is, of like terms? Sean? Good. What else? That's a comma. Do you know if there are any other like terms, Sean? Great job. So the like terms are 3x and negative 6x. And then the other set of like terms are negative 4 and 2. They have the same variable parts, therefore they are like terms. Annalise? They are. Just like here. Yep. No. That's not. That one's all by itself. Just adding and subtracting for now. Okay. That's one term. I know it's multiplication, but it's a term. So this is a term. One term. One term. One term. Okay. Charles? Go ahead. Yep, but you need to write them out. But you're right. It does. Yep. Okay, constants. Emma M, can you tell us the constants? Go ahead. No. Nope. Same variable parts. It has to have the same letter and same exponent. Okay. Okay, who can tell us constants? Alyssa? Good. Just the number terms are the constants. So -4 and 2. What are the coefficients? Justin, what are the coefficients? Okay, but just give us the number. So just the number that's in front of the variable is the coefficient. So 3 and -6 are the coefficients. They are the numbers that are in front of the variable. Okay, Annalise? No. 3 and 6 are the numbers in front of the variable. That's the coefficient. They're not constants. These are the coefficients. The constants are just the numbers. Just a number is a constant, not a number with a variable. Charles? No. Nope. A constant is a term that's just a number. 3 times x or 3x, however you write it, that is still a term. And the variable parts on that is the x. Nope. Nope. A constant has to be a number, Charles, all by itself, separated by addition or subtraction, not multiplication or division. For this section, yes. When we talk about terms, yes. Okay. Doug? Okay, then don't ask. Okay. Any other questions on this problem? We need to stay on track. Okay. So let me ask you this. If I told you in this problem to combine like terms, what do I mean by that? Anyone know? Combine like terms. Briar, what do I mean by that? Great job. What is 3x minus 6x? Emma M? Good. -3x. What is -4 plus 2, Matt? Good job. What we just did is we simplified the expression by combining like terms. This is what we're going to do whenever I show you how to distribute. I'm going to give you some crazy long expressions. You're going to distribute, and you're going to combine like terms. That's why you need to know what all of these terms mean. Okay? Combine like terms is our ultimate goal. Okay, I want you guys to try letter B. Try letter B. Put your pencil down when you're done. Matt? Done? Okay. If you're done with letter B, try the letter C. Man, you guys are fast. Okay. Okay, well then it's too easy for you. That means I need to make it harder. So if you're done with B, try C, which is on the back. No, don't try the next one. Just B and C, as far as I want you to go. No, we'll do that together. Okay, about another minute. All right, let's go back to letter B. Okay, I'm just going to kind of randomly ask you guys what you got for each one. If you didn't completely finish C, just fill it in as we go. Okay, Zach, on letter B, can you list all the terms for us, please? Uh-huh. What kind of 13? Good job. I just didn't hear you. Okay, Briar, can you list the like terms for us? Good job. What kind of 13? Good job. Don't forget the negative sign. So the same variable parts are the like terms. Adam, what are the constants? Good. Why are they the constants? Good. They don't have any variables to go with them. It's just the number terms. Okay, Sean, what are the coefficients? Good job. -7 and -6 for the coefficients. Just list the number that's in front of the variable. All right, hold on. Before you flip over, let's combine like terms together. So when we combine like terms, I'm going to circle the like terms that you guys told me that are the same, and I'm going to underline the other like terms that you guys told me are the same. Anyone want to try? After we combine like terms, what is the simplified expression? I'm making you think today. Doug, you want to try? Great job. Nope. When you're adding two negatives, remember the rule from chapter 1. Take the absolute value of them, add them, put the common sign in front. The order that you write that expression does not matter. What I mean by that is you could have -5 minus 13y. Does not have to be in that order. Annalise? So on this one, it was -7y minus 6y. You just follow the sign that's in front of it. This one was 8 minus 13. The signs they're always going to be there for you. Those are not like terms. If you have -13y. Okay, here I'll say that again. So -7y, you do minus 6y. See the sign in front of it? That's how you know. Okay, 8 minus 13. You just look at the sign that's in front of the number. Adam? Is that what you mean, Annalise? -7y minus 6y is -13y. So the -13 is there. 8 minus 13 is -5. Remember, a negative sign is the same thing as a subtraction sign. Thank you, Adam. I thought she meant adding them. Thank you. Annalise, you okay now? Okay. Zach? Are these like terms? No. So can you combine them? No. So you have to leave it like that because they're not like terms. That's why that is simplified completely, because the 5 does not have a y. So you cannot combine them. It's like saying you can take a number and put it with something that has a letter. You can't do that. They're completely different. Does that make sense? Okay. All right, letter C, let's go over. Okay, the terms, Annalise, can you tell us what you have listed for the terms? Okay. Great job. Okay, the like terms, Mary? Nope. Same variable parts. The 7x does not have an exponent of 2. What kind of 8? Good. The only like terms in this problem are the -8 and 5, because the -2x squared and 7x, remember we talked about a little bit ago, this one would be like a 2-headed cow. This one would be like a 1-headed cow, because this one has an exponent of a 1. They do not have the same variable parts. That makes sense? Okay. What are the constants? Justin? Good. -8 and 5. Doug, what are the coefficients? What kind of 7? +7. Good. Coefficient is the number in front of the variable. Okay, so now let's simplify the expression. What do you guys think the simplified expression is? This one's tricky. Adam, you want to try?
I have no
That's perfect. The order for now, I'm going to tell you doesn't matter, but when you get to algebra, the order that you put these in is from the largest exponents down to the smallest. So let me tell you what Adam did. Adam rewrote the negative 2x squared because there's not a like term that goes with it. He put the 7x next to it. It doesn't have a like term. And then he combined negative 8 plus 5, which is a negative 3. So that's where that negative comes from. Good job. Annalise. Correct. Yep. Any other questions on C? Okay, I want to do 2 more problems with you guys. Let's look at 4A and B. I'm going to save distributive property for tomorrow. So let's look at 4A and B. Okay, it says simplify the following expressions. So can we simplify letter A? Is there anything we can combine? Yep, Matt, what can we combine? Good. Awesome. I want you guys to make shapes like I'm doing. Put the sign that's in front of it within your shape that you're making. Just like Matt told us the like terms. I'm going to circle the other ones. Okay, so when we combine, what's 4n minus n? 4n minus n. Zach, 4n minus n. What's really in front of the minus n? What's the coefficient next to n? Coefficient is a number. Nope. Nope. Adam? What number is right here? 1. 3n. That's tricky. So 4n minus n is the same thing as 4n minus 1n. When you're adding and subtracting, do not add exponents. You leave the variable alone. Matt. Go ahead, next part, Matt. Good, it's a positive 2, so that's where the plus comes from. Negative 7 plus 9 is positive 2. Okay, go ahead and do letter B on your own, and then I'm going to have someone tell us what they got. No, because I didn't teach you distributive property yet. No, just B, because I didn't teach you distributive property yet. We have like a minute left. I'm not teaching us. We'll wait for tomorrow. Okay, letter B, Matt. Yeah, go for it. Great job. Raise your hand if you had that. Yay, great job. Okay, listen. Questions on letter B? Annalise? So ready? Here's a like term. Here's a like term. So 12k minus 7k. And then negative 9 plus 20. Remember, you're always adding or subtracting. You okay, Annalise? Okay. Adam? No, you have homework. I always have something I can find. Donatus? What's funny? Oh, that's interesting. Very interesting. Did you think K was 1,000? Okay, Doug, hold on a second. Let me explain homework. Okay, go ahead and take your homework packet out. Let me scroll back here. Okay, in your homework packet, there's 2 different things I want you guys to try. Okay, the first one is practice 2.3. I want you guys to do numbers 2 to 7. No. And Hold on, Doug. And 22 to 24. And one more page. Page 37 in your homework packet. Numbers 7 through 13. Hold on, there's one thing I have to explain, so don't put that away yet. So let me make sure you have these numbers written down. Practice 2.3, numbers 2 to 7, and 22 to 24. And then on page 37, which is kind of a random worksheet I had in there, all I want you to practice on page 37 are the combined like terms. So combined like terms worksheet. Now, here's what I need to clarify with you guys. On numbers 2 through 7, I want you to put these on loose leaf or in your notebook. So I'll say that again. For numbers 2 through 7, I want you to put on loose leaf or in your notebook. What you need to do is you need to list, just like we did in class, the like terms, the coefficients, and the constants. The instructions tell you to do that. Please read the directions carefully. The last part of numbers 2 through 7 asks you to simplify the expression, just like we did in the notes. Matt? Yeah, you can abbreviate. Just make sure when I'm checking your homework, I know what's what. So on loose leaf, you need to list everything just like we did in class or in your notebook. Doug, this is not on the homework, is it? Okay, hold on. Yes. You can do on the notes, yeah, on the homework packet. So the only problems I need on loose leaf are 2 through 7. This should not take you very long. However, it's extremely important that you understand what all these definitions mean that we talked about today. I'm going to make it a little bit harder tomorrow, and eventually we'll get to the distributive property. Annalise. Yeah. Well, also 22 to 24. No. Page 37 should be numbers 7 through 13. Yep. Charles. On loose leaf. You okay with that? Okay. Briar. Wait, what is first in math? 24 game? Okay. Before you leave, come up to me so I can write the numbers down. Okay, Doug, you can talk to me in a second. We need to go, so go ahead and get packed up. You're welcome.